Hi, everyone. Welcome back. So, I quickly wanted to go over the responses that I received in the Google Forms that I asked you to fill out during the first two classes. And then I think there was another form on day four that required you to answer how many questions were you able to answer. And then there was another form that went along with on Monday's presentation or distance learning thing where I had asked you to tell me the topic names where you were kind of did not understand things or along those lines. So I thought it might be worthwhile for everyone to just go through these responses, um, and maybe if you're having problems or there's something that you don't understand or it might help you. So on day one, the first response that I kind of got right here was, how was the standard of measurement made? Well, it has evolved over the years, right? We've been using measure some sort of measuring standard throughout our history, throughout our human history. And it would be interesting if you just do go ahead and do a Google search and you'll find quite a lot about how was the standard measurement made. But essentially, when you talk about time, um, it's to do with, if I remember correctly, it's to do with some electrons bouncing between two walls, and that single oscillation is to do with the smallest denomination of time. And that's how all the clocks are kept accurate, or that's how the time is being measured, and that's the standard there. For mass, is to do with a 1 kilogram round sphere of a certain metal, which I can't remember what the metal is, but there's a certain sphere made out of some metal that weighs 1 kilogram exactly, and that's where all the measurements are coming from, and that's what the entire standard is based on. So it's all of those things where I think they're setting in France. Now they might have shifted as well, or other countries have copies of the standards where they're measuring everything from. They're all exactly the same throughout. If you if you Google mass and the standard of mass, you'll be surprised that it changed recently. It changed by some point 0.00000 some figure, but what they were saying is that it will have some sort of an impact on all the other calculations or the calculations that the computer does. Um, so that's really interesting. But you can find that at this part one about yourself, and I'm glad that you had that question. Whoever asked this question, um, number two was kind of funny, interesting, where they mentioned that they're bad at physics. Well, I'm glad that you took physics, and we're trying to uh, we'll work together to help each other out and get better at physics. Number three is someone who's doing distance learning. So everyone who's doing the distance learning thing, we're using the Holt physics book. Um, I don't think you need that book per se. The book is in the class. So if you need extra help, then you can do so. We just don't have enough copies for everyone to have a copy, or a personal copy, and that's why they're not going there. However, if people who are on the distance learning program or the alternate distance learning program, if you need extra help with chapters, and if you want me to scan certain topics in, please let me know and I'll scan them in and send them to you so that you can have additional reading material. Otherwise, if you're watching the videos, if the videos are clear enough, it should help you. That well, they should that the video stuff and the examples should be enough, um, and the presentations obviously. But if you need more reading material, please do let me know and I'll figure something out. Most likely, it will be a scan, and I'll email you. Um, Notes It's up to you. If you want to take notes, you're welcome to. If you don't want to, now this varies from person to person, and it varies from the different methods that work for each individual in terms of how you're able to learn. So if you learn by writing notes and taking notes, please do so. If you are able to keep your focus and are able to learn just by watching the video, you're welcome to do that. I personally like to write notes because that's the system that works for me, because I can then go back and refer to all these things. So this will vary from an individual to an individual. So um, it's up to you totally. Um, for number five, I don't think so. You don't need to memorize all these conversions. There are some common ones. For example, a kilogram is about 2.2 pounds. A kilometer, sorry, a mile is about 1.6 kilometers. Um, so that thing. Um, but you don't have to memorize these. If you're doing some sort of a homework assignment, you've got Google in front of you. You can do conversions through there. Google Sheets got a conversion built into it, I believe, or it should do. Otherwise, if it's an exam paper, I would provide those for you, um, unless and until it specifically asks you to do a conversion. Uh, well, I haven't thought about that for that far yet, so um, I'll let you know. But I don't think you need to memorize these, because in real life you always have access to some sort of a computing system. So you can always do a quick Google search. Um, so moving on to day two, someone said that they didn't understand the directions about the car. Um, so I went back through to the introduction to physics presentation, which was the material that you needed for Unit 1. And I was scrolling through the presentation, and I couldn't recall any car example apart from, well, this one. Um, and what this was entirely, so if you really want to know about this, whoever asked this in day two, um, the entire or the full explanation is under the day one's video that is posted on YouTube. Um, but essentially, what this entire thing was talking about was that the mechanics branch right here of physics is being utilized by the car wherever there's motion. So, motion of the pistons, the tire friction, the aerodynamics of the car. So, there's all that mechanics part associated with that part, or that branch of physics associated with those objects within the car. Thermodynamics has to do with cooling of your engine, the heat generation of your car from fuel burning, and that work extraction, that's thermodynamics. There is HVAC system in placed within your car, that's causing that's all to do with thermodynamics. There's optics, so optics of the lenses, how the glass is working, how the rear view mirrors are working, so all of those. Then there's vibration, so you've got dampeners installed in your car, so your shock absorb system. They're all to do with vibrations, and then the sound deadening system that's installed by all these little um, coverings that you get on your car pillars and all of those things. They're all essentially reducing the vibrations and noise propagating into your car cabin. Electromagnetism, again, it's pretty much everywhere, but most importantly, you see that in your starter, your alternator, which is charging your battery. Then you've got your electromagnetism stuff working in within your um, car as well, with your wireless chargers these days, and phone chargers and all of those things. So, that was the car example, and it was essentially all trying to tell you that how you're using how the different branches of physics are being applied to the car, and that's what we went over. So the next question was to do with visual techniques, and the examples to do. So I was hoping is that Most of you would do Google search and how to plot data. Um, and a big part of this class is that I want you to become independent learners. So when you go to your university after this, after school, they're not going to guide you. So you'll have to find um, resources and how to use the different resources that are available to you rather than the teacher or the professor at the university who's going to explain to you and give you a step by step detail. Um, so I want you I want to mentally prepare you for that experience rather than you go there and get a mental shock of what do I do next. So that was my entire point. I went over the different visual technique examples, but you trying to figure out Google Sheets, um, I was hoping that you would do so by yourself. And again, I'm not fully aware of how much technology usage or how much experience with technology you have under the belt, and that would vary. I can understand that, but that's one big assumption that you would be figuring these things out by yourself. And if you get stuck, you're welcome to email me. Uh, but other than that, it's kind of there. But we will I will wait for this one. Or the visual techniques part because I've got that covered. I've got that spreadsheet open for you, which I will talk about because it's got some other people have questions related to the assignment, so I thought I'll wait and we'll talk over it. Um, so number three asks that they're confused on the application for the assignments and some instructions unclear, and so that sort of thing. Um, so one thing you can do is what my Chromebook came installed with or pre-installed with is if I open this up, um, I've got So I tried this explain everything thing. It's not free, so I don't recommend it. You can do a video thing, but um, this is not free, so I won't recommend that you use this little parts to explain everything. Um, that isn't worth wasting time on. The next thing that came pre-installed was the Chrome Canvas. Chrome Canvas is good. So if you're not using a handbook or loose papers and you want everything stored onto your Google Drive, just use Chrome Canvas. Um, and that should allow you to do your handwritten solutions, take a snapshot and do an attachment that way. So you can use Chrome Canvas, or you can use, let's say, where did it go? So um, let's go to Jamboard, and with Jamboard, what you can do is you can do, well, I will create a new Jamboard whenever it opens. Um, you can scribble whatever your answer is. So your solution to, um, let's say your solution to problem, whichever one that is, you can do it this way. You can hold your um, Chromebook in a portrait manner, and you can answer that way if that makes it easier. And then click here, take capture a region or capture screen, and you can do that. It will take a picture for your entire thing. Copy that image into Google Docs, um, and you can submit that answer that way. It all depends how you want to use it. So, um, again, it's the tools that you are able to use with your to answer the questions that I'm asking you. It's all up to you. Um, Question number two was to do with, or sorry, we've already done three. Um, Parallax errors. Parallax errors are to do with your Parallax errors are to do with the accuracy when you're measuring something. So if I go to my Jamboard here, for instance, so oh, no, let's do this clear frame. So for instance, if I'm using a scale, right, what parallax error does is, so if these are the markings on my ruler, if I want to get this reading right here, um, what parallax error does is that, or what it measurement requires me to do is place my eyeball right on top, right? So I'm looking at it right vertically right on top of it to do the reading. If I were to move around here, or if I were to move around here and look at it, I might not get this marking. I might be looking at this marking, or I might be looking at this marking. So that's all to do with parallax errors. Or if you fill up a clear glass of glass of water, right? So if you fill that up, what you notice is if you were to hold it parallel to yours, so if this is the level of water, right? Um, Usually what happens is with water, because of the surface tension, you get this low level that's built in because the water sticks to the glass on these sides. So if you were to look at the water from this angle, right, what you will the level would seem that the glass is filled at this point rather than where it is at this point. So in order to get a proper reading, you have to be level to the or view the glass from standing look at the glass where you're standing in level sight of where the water level is. So you have to be directly perpendicular to it, or your vision side, line of sight is supposed to be directly perpendicular to it to get to avoid any parallax errors, and that's to do with parallax errors. Next question is to. I hope that answers the question. If it doesn't, please let me know, and I'll try to find a YouTube video for you to watch because I cannot demonstrate that in class. Um, and I don't know if you've got enough beakers in the classroom. I think we do, but um, we cannot pass it along during this time. But you could, if we weren't doing what do you call it, safe distancing or social distancing, I would have asked you to get out a beaker, fill it with water, and measure what the level is, and that would have explained what parallax error is. Um, So to do with the creation of the seven base units, or creating new units from seven base units, um, I thought I'd done this before, or done a relatively good job trying to explain this. But essentially, what you're trying to do with creating, so the seven units that we talked about were to do with mass, light, electricity or current. Then there's amount of matter, there's length, there's time, and then I'm forgetting one more. But so there are seven base units out of which you can create more units. So for example, if I'm giving you speed, speed is created from two base units, that is length over time, right? Or the units are meters per second, or miles per hour, or kilometers per hour, or whatnot. So that's one way of creating new units from those seven base units. Or if I'm asking you um, how dense is a subject or an object, you're basically measuring density, which is measured in, again, kilograms per meter cube, which is, again, the top one is mass. So you're using mass as base units, and you're using base unit of length here, which is cubed. So length is cubed. Um, and you're using these units, or these base units, so from mass and length, to create new units right here, which is kilograms per meter cube. So the next part was, well, why and when are we going to use units of measurements in physics? Um, so let's go back here, go to Jamboard, and let's say I write down this number. Oh, okay, I've got a laser pointer on, but let's say I write down this number right here. What does this mean? It says 2, but that's it. It doesn't mean anything. So if I were to write S next to it, that means 2 seconds. Now you know that I'm talking about time. Similarly, if I write down 10, again, that doesn't mean anything. If I were to write newtons next to it, then you know that I'm talking about force here. Now you will see in the next chapter, once we reach forces and when we start talking about forces, When I say newtons, you can automatically assume, well, newtons are formed from base units. And weight, if you did that example in our lesson, that is given by mass times gravity. So you're multiplying mass with gravity, and gravity is a form of acceleration. Um, and given the last topic, acceleration is the time rate of change of velocity, right? So you've got velocity, change in velocity by change in time. So you've got units here, which are meter per second divided by per second, and you get meter per second squared. That's your units for acceleration. And then you've got mass, right? Mass times gravity, or which is acceleration again. So essentially you're multiplying kilograms with meter per second squared, which is also in common language referred to as newtons. So going back to the original case where I said, well, 10 newtons, you can say it's also 10 kilograms per meter. Sorry. Um, 10 kilograms meter per second square, from which you can also work out, since gravity is almost equal to 10 um, meter per second square, you can say that I'm talking about 1 kilogram. So units are very important, what I'm trying to get to. If I were to just write a singular number, it doesn't make any sense. You can say that it's 10, but you don't know what 10 is standing for. If I wrote down newtons, you exactly know what I'm talking about, which is that I'm talking about force. And then retrospectively, you can also work out, well, what are the common denominations here, right? So you can do all of those things. So the next question is to do with, let's say, where we are, measurements of physics. We've done this. 7 is saying that when it comes to a video for a project, please refrain from explaining something that is not relevant to the project because it will confuse us. So, yeah, I don't know how to answer this one because it's, as a teacher, I believe I should be doing a bit more than the subject itself, right? I should be uh, adding some extra information here and there because it will help you at some point. Um, so I don't know. I don't know how to. I'll try to stop doing it. That's all I can say, but I can't promise anything. Um, Number 8 says I would try to shorten the videos a little bit. That's what I've been doing this time around. They're reduced quite a bit. So it's reduced from 60 minutes to anywhere from 20 minutes. I'll try not to get them more than 20, 25 minutes. But again, it all depends on the topic and what we're trying to do. Um, Number 9 asks or says that for scientific method, if you move the decimal point to the left, is the number to the 10th positive, and if you move the decimal point to the right, it would be a negative. So going back to this little um, untitled jam here, let's clear the frame. So if you're saying that if you've written, let's say, 100 into 10 raised to power 3 in scientific notation, um, let's say there's 10.01 here, right? So what I can do then is, if I were to move the decimal point to the left, uh, and this would become 10.01, what I would be doing is I'll be adding 1 here, so that's yes. That'll be addition. If I were moving the decimal point to the left here, then yeah, you'd be taking, oh sorry, to the right here, then you'd be taking 1 out, and you'd be getting. So yes, your question, what you've asked, is completely correct. If you're moving the decimal point to the left, you're adding. If you're moving the decimal point to the right, you're subtracting. I believe that was the question. If I've answered it incorrectly, or if that wasn't the question, please do let me know. Send me an email. The next part was to do a day 4. Day 4 did not have any questions. All of you had an assignment to do, which most of you got the questions answered. Some of you did not get all the questions answered, and that's fine. It was assignment that was due within a week. Um, Now, before we start with week two's question, um, there's one really important thing that I want to mention, and that is to do with submission. I went through the course syllabus, and I thought I'd included this information there, but I hadn't. However, if you do look through your course syllabus and you um, read through the assignments part, the assignments are due after a week. So the homework assignments, not the in-class assignments. The in-class assignments are much shorter, and they are due by 5 p.m. The same day. However, it is my personal belief that I want you to use your time well, and I want you to learn. So if you need more time to do something properly, and the first score, if I can understand that sometimes um, you might not be able to complete the assignment, just send me an email that you're struggling with the assignment. Send me a snapshot of how much work you've done and where you're struggling, and I will take that as an attendance. But please, if you need more time, just let me know, and I'm fine with giving you more time. As far as improvement is concerned, once I have graded your assignments and submitted back to you, as you saw in the first assignment that I had handed back to you, which was to do with the graphical techniques, what you'll see is I will write some sort of comment on it rather than telling you what the actual or the correct answer is. Um, and what you can do with that information is try to find out what the right solution is and resubmit it back to me. There's no penalty for you to either submit your work late or to submit your work incomplete if you need more time. What I want to emphasize is, or what I want to focus on, is your learning process. So if you need more time to finish your work, please do take that extra time, but do the work to the best of your ability rather than doing a rush job at this point. Um, so there's no penalty if you submit an assignment late. There's no penalty for submitting an assignment as many times as you want for a regrade or re-explanation, or for an improved grade. I won't deduct points for that. However, this does come with the fact that whatever those course deadlines are. So, for example, quarter one is going to be one deadline. The end of semester is going to be another deadline. Once those marks have been put in, or points have been put in, they cannot be modified after that deadline. And you need to submit everything at least a week before that deadline so I can grade and return those things to you. That's one thing I wanted to get out of the way, because I haven't said that, and I thought I'd included that into the course syllabus, but I haven't. So I'm really sorry about that. But that's my class procedure, or homework procedure. There are no resubmissions for quizzes and tests because we don't have enough time this year to do those. Um, but everything else can be resubmitted for a regrade, and that sort of thing. So moving on with week two, and there was only one form this time. It has to do with that was on this past Monday. There was this Google Earth and Google Maps activity that people had concern or questions with. There's the accuracy versus precision part. Now, to start with the accuracy and precision part, what I want to say is, uh, again, accuracy is the exact answer, right? So if I'm measuring, let's say, 12.1 centimeters using a ruler, that's the accurate answer. Precision is going to be depending on the instrument that I'm using and how close of an answer I can get to that accurate answer. And those are the two things. I hope that that's the easiest definition I can get for these two, or the difference between these two. More displacement examples. I will try to include that in the next assignment. Frames of reference. That's a topic that wasn't clear. I don't know if it's clear after day two's assignment. So if you don't know, or if you still have questions with, please let me know. But essentially, a reference frame allows you to locate or track an object, right? So let's say if I'm sitting in my office, or if sitting in my teacher's chair and I want to see where everyone is sitting, I kind of have that seating chart, and that tells me where everyone is located. Now, on that seating chart, I haven't gotten the distances done, but essentially, each table right now is about a yardstick away from each other, or each chair is, and that's how I can kind of work out where each one of you is sitting in the designated position. So that's what a frame of reference allows me to do, which is essentially I know the position of each and every one of you sitting in my class, right? Based on wherever that frame of reference is, or wherever the teacher's desk is. So it's a fixed point from where you try to locate different things, right? Number five is asking what is an answer write up. So answer write up, like I said before, it's all the technological means that you've got for yourself, and you're just trying to submit an answer to me. So it could be Google Docs. So let's say it could be Google Docs right here. You can use Google Docs. You can use this Jamboard. You can write something up. Take, let's say, capture this region. I've captured it and copy to clipboard, go on to Google Docs, and I can paste it right here, right? So you can use this, and if it's a multiple assignment sheet, and you're working through those, you can solve everything in your Jamboard, take a picture, post it here. Um, so that's what I meant by answer write up. For the things that you can't type and you need to do mathematical working and show me mathematical working, that's what I meant by answer write up. For everything else, just please type it up into Google Docs. It makes things easier for me. And that's sort of it. And then the last question is, or it's more of a comment. You assume that we knew everything. Don't only tell us what we need to know for the assignment. Again, it kind of meets up with this little statement up top here, where it comes for when it comes to a video project. Um, again, I haven't assumed that, and that you guys know everything. Um, I would like to say that you know more than I do in terms of technological things. Um, so yeah, I'd say that because you're younger than me, and technology appeals to the younger crowd more, um, and you're more on top of things rather than uh, the older generation. And the older term is relative here, but that's one thing. Um, Again, and then part of that being a student teacher thing is that I have to give you more information rather than giving you just the specific. The specifics are for you to find out. Um, so I want to get that thing out of the way, that there's always going to be more information available for you. And that's all to do with explanations and some other elements that are just added there, so you can correlate things. That makes them easier to associate and help you learn stuff. And they're just there for that matter. So the last thing I kind of or want to come back to is this Google Earth thing, and then help with the visual techniques, right? Because that's something that most of you are struggling with. So I don't exactly know what the question is in terms of Google Earth and Google Maps, but let's move on to Google Maps, and let me do search for Chaminade, right? Because that's the example that I've been using mostly. Um, I can do the directions to it from, let's say, Kettering Labs. That's where my lab is located, or the lab that I work in, um, at the University of Dayton. So that's one thing. So what I really wanted to tell people, because I'd asked you to do five routes. Now this will Google will automatically give me three routes, or depending on where you're staying and what you're trying to measure, two or that sort of thing. But then there's this thing that if you move on to that highlighted route and move this little white cursor that pops up, you can alternate it and you can find a different route. So I don't know if you knew about that. Um, but you can do all of these things, and it all depends how you want to use it. So there are different things that you can do within Google Maps to get, or for Google Maps to generate five separate routes for you. Um, so that's one thing, uh, and that's something that I'd assumed to answer the other statements that people had mentioned, that I shouldn't assume too much. So that's one assumption. Um, so that's I don't know if it's my fault or not, but that's what I'd assume that you knew that you could do within Google Maps. Um, Google Earth, on the other hand, this hasn't launched still. Um, so on for Google Earth, let's see if I can assume, right, move in here. Where is Ohio? Ohio is somewhere around here. So there's Indianapolis, there's Cincinnati. So I can move in here, right? Um, let's go back to Dayton again. Um, so that's just one thing that I was telling that I could sort of use this scale right here, and I can click here, and I can draw a point, and it will tell me what that displacement is, right? So here it says distance, but that is displacement. So I can do that. I can do it in centimeters. It will change that level. I can click done, um, and it should have done that, but I think I forgot to. So here's the starting point, here's the end point, and that's what it's telling me. So you can do it in centimeters, meters, kilometers, nautical miles, inches, feet, and all of those units that are existing, right? So I don't know what smooths is, but yeah, these are some things. These are the tools that you can use. Now, on to visual techniques, and somebody sent me some data uh, to do with the last problem that you're working with. So I think this was for day one, and you could essentially use this to work out the other parts. So they were having problem with insertion of a chart. What I can do, I can tell you this, is that if I were to insert a chart here, um, here charts given here, what I can do now is I can do a x-axis data, which is already, I believe, highlighted here, but I can do it again, which is that it will do this. I'm using a column chart for my actual data. What I'm doing is I can, let's say, delete this, add another range, which is going to be this part, and I can click OK. Now nothing happens. And the problem with this is because you're using a bar chart, you can have a combination of digits and letters here, but you cannot have it for the y-axis. So what I would do rather is I can just type that in. So 14.7, 17.6, 17.1, 12.5, and 12.9. Right, I can do that, and that's the same distance that they're having. So I can do all of this. Now I can edit my chart. Um, and I can select the range here. So the data range here is I can remove this too. And instead of the B2 to B6, I can do C2 to C6. Now let's see. So now see that it's working. So that's one way you can do a bar chart. You can convert this data again to scatter plot as well, but see x-axis will not come up. Let's select this as well. So the data range is the right options. that you had. Um, so they will come up on x-axis. So you can use on x-axis, you can use a combination of letters and digits, but for the y-axis, no, because you're measuring that, and Google will not allow you to plot or write this thing down. So if you remove the miles from this, it would populate. For the speed part, all you had to do was divide everything by time and just do that. So for instance, if this took me zero point 0.1 of an hour, and then this was zero point 0.2 of an hour, zero point 0.5, let's say zero point 0.4, I'm trying to generate random numbers here. My speed here would be, right, so this is time, and then this is in, I will label it, so I don't have to label it here. That's another part of data presentation. This is distance, but I can write miles here so everyone knows that all this column is measured as a measurement in miles. This is all in time. Speed is again going to be, if I'm going to simply divide this, this is going to be in miles per hour, right? So, and all I have to do is click on this column, divide it by this one. So that will tell me what my speed is, right? So I can move this over here, and that's what the different speeds were. And I believe for displacement, the displacement won't change. So displacement was something that you needed to find out through your Google Earth part, and your velocity would then be simply whatever this value is. So whatever this value is divided by your time. And that's what your velocity was going to be. Again, displacement is something that's going to be in miles, and then velocity is going to be, again, depending on what these units are. So displacement in time units, it's going to be, in this case, it's going to be miles per hour, right? Um, so that's one thing you can do. And again, under edit chart, you can change your x-axis and y-axis data. So right now I can change my x-axis to, let's see, D2 to D6. If I hit OK, see that it changes now. Um, so you can add all sorts of information. You can do a scatter chart, you can do a line chart, you can do a smooth line chart, which is the next one, um, and all those things, right? Pie chart won't fit here, but you can use all the different charts that are available to you, depending on the type of work that you're, or type of data that you're working with. So I hope this kind of answers your question regarding visual techniques and whatnot, and this has helped you with using the example that we were discussing in class. But if there are any other questions, please do email me. If I haven't been able to respond to your email, there's a chance that I've missed it. Please send that email back to me. I'm getting more than 60 to 70 emails a day from the CJ account, so it's kind of hard to track where everything's coming in. And if I do tend to forget things, so if I have not emailed you back, please let me know. But I'm trying to stay on top of the emails. I'm trying to respond to your comments that you're putting up on the Google Classroom assignment page, or just sending me general emails. Um, so I hope this answers your question. Apart from watching this video, please let me know if there are any more questions. So send me those questions. Um, and use the rest of the time or class time to work on the assignment that is due today, which is to do with the Nobel laureates. So for the Nobel Prize winners, for the essay, you're writing at least a page and a half. Um, the more you can write, the better it is going to be. Um, and for the presentation, please include all the information that you've included in your essay. And the presentation would allow you to include pictures, their findings, and all of those things. And then again, this is an exercise to help you build up your skills that you will need in college. Um, so I hope this was a helpful video today. It might be longer than the 20-25 minute mark. Um, but it has to do with what you've done or the questions that you had for the past a week and a half. Thank you, and have a good day. Bye bye.